Now I am going to demonstrate about Anesthesia workstation. This is made by Biomedical systems and the model is Jupiter Plus. This equipment is used to manage and control the respiration and anesthesia, which delivers the fixed portion of mixture of gases, which include life-sustaining gases and anesthetizing gases. Anesthetizing gases are isoflurane, vasoflurane, sevoflurane. The anesthesia machine is intended to use only in operating rooms and emergency rooms, not suitable for other places. It can only be operated by anesthesia specialist. Now let's see the different parts of the anesthesia workstation. Now let's see the different parts of the anesthesia machine. This is the ventilator section, this is the vital sign monitor, this is the vaporization chamber, these are the flow meters, these are the pressure gauges, and these are the drawers for placing accessories. In anesthesia machine we have two breathing circuits, one is closed and one is open. To switch between them, this knob is used. This is the O2 flush, which gives the 35 to 75 liters per minute when it is pressed, and this is for common gas outlet, which is used when the open circuit is on. And this is the breathing system module. This is the rear view of the anesthesia workstation. Here you can see the gas supply system. Here we have 4 cylinder yokes. 2 are for nitrogen, these 2 are for oxygen. Here we have 3 pipes inlets. One is for oxygen, one is for nitrogen, and one is for air. Here we have 2 electrical outlets. This is the main supply to the anesthesia workstation, which operates in the range of 100 to 240 volts AC, and the operating frequency is 50 to 60 Hz. These are the 2 electrical outlets, which outputs the voltage of 240 volts and delivers the current of maximum 2 amperes. And at present one of it's connected to the patient vital sign monitor. This is the pressure relief exhaust. When the pressure increases in the pneumatics, it releases the pressure, so we shouldn't obstruct this valve. Now let's see the breathing system module. Here we have the bellows assembly. Here we have the circle system, in which we have the inspiration port and expiration port, pressure gauge and the O2 sensor. And here we have the airway pressure limiting valve. Here we have the vent or back switch. Here we have the absorber on off switch. This is the mounting out to which we connect the reservoir valve. We have the canister which holds the soda lime up to 2 kg. Airway pressure valve is used to set the pressure with the help of knob when the patient is manually ventilated with the help of breathing bag. Inspiratory port. The delivery of gas to the patient is done by connecting the pipe to the inspiration port of the circular absorber. Expiration port. The expired gas from the patient enters to the circular absorber by connecting the pipe from the patient to the expiration port, and the expired CO2 gets absorbed into the breathing system, which is delivered back to the patient mixed with some amount of fresh gas through the inspiration port. The bypass switch in the circle absorber is used for bypassing the circle absorber from the patient circuit for changing the soda lime during the ongoing procedure. Manometer shows the reading of the pressure exerted on the lungs of the patient. Back to ventilator changeover switch. This switch is used to change the driving of machine from manual breathing back to the ventilator. Bag arm is present in the circular absorber for mounting the breathing bag when the ventilation is manually done with the help of breathing bag. In ventilator section we have a 7-inch color TFT LCD display, 4 keys, those are menu, alarm, silence key, back key and standby key. We have a encoder key which is used to navigate the menu. Here we have a on off switch to switch on the ventilator. At present the machine is on standby mode. To change the mode, we have to press on the menu button, and here you can observe we have ventilation mode. By clicking on that we can change the ventilation mode. We have 4 types of ventilation mode. One is volume control ventilation, one is synchronous intermittent mandatory ventilation, one is assist or control mode, one is pressure control ventilation. So we can select the patient type, whether adult or pediatric. To start the ventilation, we have to switch on the vent or back switch. After switching on it, These are the set parameters, these are the measured parameters. Here we can observe the mode of ventilation. These are the waveforms and loops. Here we can see the power status, whether it is running by battery or AC supply. Vaporizers are used to convert the liquid anesthesia to aerosol for patient administration. Here they provided the 2 slots for vaporizers. The flow meter displays the flow of gas, O2, nitrogen and air. The value can be read directly. The unit is liter per minute. Rotate counterclockwise to increase and rotate clockwise to decrease. These are the pressure gauges which measures the cylinder pressure and the pipeline inlet pressures. These 2 are for nitrous oxide cylinders, and these 3 for pipeline inlet pressure, and these 2 for oxygen cylinders pressure. This is the oxygen failure alarm, gives the visual and audible alarms when the oxygen pressure drops below recommended value. They also provided the patient monitor to simultaneously measure the physiological signals of the patient. Those are ECG, respiration, SpO2, temperature, NIBP and pulse rate.